Hello everyone and welcome to another video of Vivek Learns. In the last video of PepCoding Level 1 that we had made, we had solved this question, which was next smaller element to the left. So in this video we will continue to solve the stacks and queues module. Next question, which is stock span. So what is the question? You are given a number n representing size of an array A. You are given n numbers representing prices of share on n days. Okay, so we are given the prices of shares. You are required to find stock span of for n days. So what is stock span? Stock span is defined as the days passed between current day and the first day before today when the price was higher than today. Okay, so current day is this day and the first day before today, so it will lie somewhere to the left before today when the prices was higher than today. So if when was the price higher than this? When was price higher than 2? We don't have any data. So we just print it was higher for this day only. So when was the price higher than 5? It was higher on the second day only. Like and when was it higher than 9? It was higher on the third day itself because this is the highest price till now. But now here, if we see which was the price, which was what was the difference between the days when the price was higher than 3. So the price was higher than 3 on this day. So what is the difference between these 2 days? It is 1. So that is how we will find the stock span. So let me have this array here, and if we see there is no element which is greater and to the left of this. Similarly for this, similarly for 9. But we have an element which is greater to the left for 3. So 9 is greater than 3, right? So what do? We just insert 1 here because it was present on the previous day itself. For 1, which was the element greater than 1 to the left of 3. Difference between those 2 days is 1. For 12, there was no element greater than 12. So we'll print just 1, 2, 3, 4, 5, 6. Like on the 6th, 6 will be the stock span for this. For 6, it will be 1 because it was the price greater than left was present 1 before. For 8, it will be 2, right? Yeah. And for 7, it will be 1, right? Because 8 is present here. Yeah. So that is how we find the stock span. So let's try to have a greater element to the left array, right? So element greater to the left of 2 is -1. Similarly for 5 it is -1, for 9 it is -1 because there is no element which is greater than 9 to the left. But for 3 it is 9. For 1 uh, it is 3. For so for 1 it is 3, right? For 12 it is -1 again, right? For 6 it is 12. For 8 it is 12 again. For 7 it is 8. So we have 9 elements here, right? 4, 5, 6, 7, 8, 9. Yeah. So this is how we had calculated the greatest element to the left array. So wherever we have -1, the stock span will be index plus 1, right? So that is how we have found the observations, right? So what will we do now? We'll try to solve this question in a similar way that we'll try to solve next element next element to the left, which is next greater element to the left. So we'll create a new class called stock span, and we open that class, erase this logic that we had. But the catcher is that instead of inserting the element, we insert the index, because we want differences of the indexers, right? So we insert 0 here. For ARR of 0 we insert 1, right? Yeah, because the stock span of this 0th element is always 1. So now we'll start the iteration from 1 till ARR dot length word -1. And what do? We iterate and we try to find if ARR of I is greater than, sorry, ARR of stack dot peak, because stack dot peak will have the index, right? So for, let's write the stack first, right? So what will happen? For the first, we have the stack containing 0. So what will happen when we start iterating from 5? Is 5 greater than stack dot peak, ARR of stack dot peak? Like, is 5 greater than 2? Yes, 5 is greater than 2. So what we'll do, we erase this, and then we hit an empty stack, right? So we push ourselves, like our index, into that, and we insert -1, because -1 here, right? And then we'll replace this -1 with the index plus 1, right? So what do we do if stack dot peak is empty? So we keep popping. So we keep popping till we have an empty stack, or till we have an empty stack. If stack is not empty, and then what do? We stack dot pop. And once we pop, if we hit the bottom, what do? If stack dot is empty after popping, then we do result array of I is equals to -1. We insert -1. Else, what do? Else we insert. So let's try to identify what do we do if the stack is not empty. So we inserted 1, right? Then we compared, for the next iteration we'll compare 5 with ARR of 1, which is 5, 9 with ARR of 1, which is 5. So 9 is also greater. So we pop this, we find an empty stack. So we insert -1 into the array. So that is what we are doing here. We are inserting -1 into the array, and then we push. What do? We push this element, which is 0, 1, 2, 2 into the stack. Then we see for 3. Is 3 greater than stack dot peak or ARR of 2? because stack.peak is 2, right? So if is 3 greater than 9? No. So what do? We have the span as the difference between those two indexes. That's what we'll do, right? So we'll have I is greater, right? Add minus stack dot peak, correct? Right, and if this condition is not true, then we have we'll have a similar case, right? If stack dot peak ARR of stack dot peak say this 1 is smaller than this, so what we do here? We subtract the indexes of diff2, right? Yep, that is what we are doing here. So once we are done having this logic, what will we get? So we will get an array which is something like which contains -1, but it doesn't contain the element greater to the left. It will contain their difference between their sums. So let's try to identify that. What is the result array that we are going to get? So for 3, the element greater to the left of 3 is 9. What's the difference between 3 and 9's index? It is 1. So we'll get 1 here, right? And for 1, what is the difference between what is the element greater than 1 to the left? It is 3. And the difference between their sums is the difference between their indexes is 1. For 12, there is no element which is greater than 12, so we insert -1. For 6, 12 is the element which is greater than 6 to the left. So the difference between their indexes is 1, right? For 8, 12 is the element which is greater to the left. The differences between their indexes 2, right? For 7, 8 is the element which is greater to the left. Differences between their indexes 1. So this is the output that we will be expecting after we iterate. Like we'll have -1 instead of the indexes here, index plus 1s here. So let's try to run this once. 9. Let's see, what do we have? 259. 5913, right? 31. Let me have that again, run again. 3, 1, then 12, right? So we got a stack exception. Where did we get it? On line number 23. 23. So when will we get a stack exception? Yeah, we may get a stack exception here, right? So let's have stack dot stack empty exceptions. When will we get a stack empty exception? Let's try to debug this code. Let's have an debug point here. Let's try to debug this. And we want to switch to the debug perspective. Let's see the elements after debug. Yeah. So is ARR of I ARR of I is 5. We have ARR of I is 5. So is 5 greater than stack.peak? ARR of stack.peak, which is 0. It is not. So we'll insert. Oh, so we are missing one point of adding the element to the stack, right? So irrespective of us doing anything, we have to push I to the stack, right? That is what we found. Terminate it once. Because what we do is, in any case, we have to push I to the stack. Because what happens is, even if we pop and we hit the empty stack, we have to push I, right? And even if we find an element which is smaller, like this case, while iterating, then even in that condition we'll have to push. So let's try to run it in the Java perspective. So we have 5. Let's try to compare these elements. So we have -1, -1, then 1, 1, -1, 1, 2, 1, right? Yeah. So we have to insert -1 for the first one, right? And what do we do after this? We iterate over the array again, and whichever elements are present having -1, we have those elements replaced with index +1. So if ARR of I is equals to -1, then ARR of I is equals to I plus 1. And this is how we'll find the stock span, right? So this will be the final result of stock span. Let's try to run it for 9, right? We are still getting -1. I plus 1, right? Okay, we have saved this also, right? So if ARR of, oh, not ARR, we have to iterate over result array itself, right? So if result array of I contains -1, then we have to replace it with I plus 1 right here. So we'll have 9, 2, 5. What was the array? 2, 5, 9, 3, 3, 12, 6. And we have the output something like this. Let's try to compare it with the stock span that we have written here. Yeah, so 1 2 3 double 1 6 1 2 1. Yeah, so this is the expected output. So this was all for this video. See you guys in the next one. Thank you.